Hello programmer, welcome back to today's tutorial. We are diving into the realm of polynomial regression, an advanced technique in machine learning that allow us to capture nonlinear relationships between variables. So join me as we explore the theory behind the polynomial regression and implement it in Python. Okay, so let's get started. So first of all, an introduction to the polynomial regression in machine learning. Okay. So the polynomial regression is while a linear regression models relationships with straight line, real world data, often the more complex is shown. The polynomial regression extends our capabilities by fitting curves to our data and enabling us to model intricate patterns. Okay. So it's great for the nonlinear regression and higher degree. So the capturing curves and bends in the data for nonlinear regression, and the higher degree is expanding the model's complexity with polynomial terms. Okay. So now in this polynomial regression is involved the fitting the equations of two data and allow us to the better capture to underlying patterns. Okay. The equations takes the form is y equal to b0 plus b1 x and b2 x whole square for bn for x power n. So in this equation are created for the polynomial regression. So here n is the degree of the polynomial regression. Okay, so let's create it. So now I am implementing the polynomial regression in Python. Okay, so it's implement the polynomial regression in Python using the is for Scikit-Learn library. The powerful library makes it the shameless to apply for the advanced machine learning technique to our data. Okay, so now I am create the generate some random for demonstration. Okay, so let's create np dot create is random and dot create the sheet. Okay, then the sheet is the value is 42. Next time create for the is x equal is 6 and multiplication np dot create is random and create for the rand value and parenthesis for 101 and it's the subtraction for 3. Okay, so next line I am create for is y equal to its floating point value 0.5, then create for is multiplication and the value is x, then its multiplication x and create for is double for multiplication 2. Okay, so it's line completed and now I will create for the addition plus x, it's addition x, it's plus for 2. Okay, so now I am create is the again for addition. Okay, then create for np dot is for random, then create for is the rand. Okay, so in this for numpy is dot random mrand. Okay, so it's create the value is 100 for 1. Okay, so its line are completed and next line I am create for the transforming the feature to indicate the polynomial terms up to the degree is 2. Okay, so let's create. So first time create is the poly. Okay, for short form is the polynomial, it's poly, then create for is underscore is the regression. Okay, so the equal for linear regression. Okay, so next line I am create for again poly and it's the polynomial regression dot create for the fit. Okay, then free fit for is the parenthesis create. So but I am not declare in this feature, so in this code next create, first of all I am create the polynomial feature. Okay, it's poly underscore its features equal, then create for the its polynomial feature, then parenthesis create is degree. Okay, its degree equal 2. Then I am create for is include underscore base for false. It's false. Okay, it's capital word. And next time create for the it's x for underscore, then create for poly, it's polynomial, then again create is poly underscore feature. Okay, then create for fit, and then underscore create for is the transform. Okay, so it's transform the x value. So now I am create for is a linear regression model. Okay, it's the poly underscore regression, then it's create for the x poly. Okay, x underscore poly, then create for y. Okay, so next line I am create for is the visualize the polynomial regression curve. Okay, so first of all I am create x underscore is new. Okay, then create for is np dot is the land is for line scope. Its line for line scope is for starting for -3. Then create the value is 3. Then create for 100. Okay. And now I'm create for is the is ray scope for the in this code for self shape and order. Okay. So this line use for create is 100 and 1. Okay, so it's line completed. And next line I'm create for is x underscore for new value is underscore for poly. Okay, it's polynomial. Then equal pol is again poly is features. Okay, the features dot create is for transform. Okay, is for transform for x underscore new parameter. Okay, so next time create for is the y underscore new. Okay, then it's equal for create the is polynomial underscore is the regression. Okay, then create for dot is predict for self x. Okay, so it's x new is for x new poly. Okay, so it's line completed. And next line I am create for is the plt dot create the scatter. Okay, it's scatter. Then the scatter for the value is x and create for y, and then create for is alpha equal for 0.7. Okay, so next one I am create for is the its level. Okay, level equal the single quotation create the original data. Okay, its original data. Next line I am create for the it's for transform x. Okay, so in this x for indicate. So now I am create for is the plt dot create for the plot. Okay, so now I am create for is parenthesis x for new, and also create for y underscore for new, and also create the color. Its color equal the single quotation create for and the green. Okay, so next line I am create for is the line width. Okay, its line width is equal for 2, and I am last one create for is the level. Okay, its level equal single quotation create the polynomial regression. Okay, it's regression. So this line completed, and I am create for is the plt dot title, then parenthesis for single quotation is this line. Now copy. Okay, it's copy and paste for in line. Okay, so the polynomial regression in Python. Okay, so this line completed, and I am create for is the x level and y level. Plt dot x level for parenthesis single quotation create is x. Okay, so now I am create for is plt dot for y level, and then single quotation create for y. Okay, then I am create for is the plt is legend. Okay, it's legend. Then last one I am create for the plt dot show method. Okay, it's are completed. So in this tutorial I am create for the generate some random data for transform the features to indicate the polynomial terms and create a polynomial regression model and visualize the curve. So this allow us to how see how well the polynomial regression fits the data. Okay, so now save this code and let me run this code. So run. Okay, so just wait for a few seconds. Okay, so this is the result for the polynomial regression. Okay, it's create for the original data and then create for the red line is the polynomial regression. Okay, so in this for the x level data and it's the y level. So in the 0 indicate for x and in this the 4 for the y level data. Okay, so here we are the mastered polynomial regression in Python. So an essential skill for capturing nonlinear relationships in your data. So keep experimenting your code and keep turning this curve and your coding through. Okay, so thank you for watching and happy coding.